This video is about another fundamental concept of thermal physics, specific heat. When energy is added to a system and there is no change in kinetic energy or potential energy of the system, then the temperature of the system usually rises, except for the case when system undergoes a change of state, that is phase change occurs. Once again, we will go back to the example that we discussed in the video of temperature and zeroth law of thermodynamics. Now, two non-isolated system 1 and 2 are kept in a thermally insulated container. This is system 1, this is system 2, this is thermally insulated container. Say temperature of system 1 is T1 and temperature of system 2 is T2. We assume T1 is greater than T2. Now, as they are non-isolated system and we assume they are in thermal contact, so after some time they will be in thermal equilibrium as energy will be exchanged between them. At thermal equilibrium, system 1 and system 2 both has the same temperature. So at thermal equilibrium, temperature of system 1 is less than its initial temperature and temperature of system 2 is greater than its initial temperature. Say at thermal equilibrium, temperature of system 2 is T. Then the rise in temperature is delta T, that is T minus T2. Now, if the system's mass is m and q amount energy is required for delta T unit rise in temperature, then the specific heat of the system is defined as C equals to Q by m delta T. So, specific heat of object is the energy that is required to increase the temperature of 1 kilogram of the substance by 1 degree Celsius. We can define another quantity that is heat capacity, which is the energy required to increase the temperature of any object by 1 degree Celsius. Now, I want to mention some important points about specific heat. 1. The energy transfer process can be anything. It can be work done, it can be radiation, it can be heat, it can be matter transfer, it can be electrical transmission, or it can be mechanical wave. Specific heat is a positive quantity. If energy is sucked out from the system, then its temperature decreases, then Q and delta T both are negative. So, ultimately C is positive. Point number 3. Specific heat varies with temperature. If the change in temperature delta T is too small, then C can be treated as constant. If delta T is not too small, then specific heat is defined from this equation. So, when delta T is not too small, C is a function of temperature, that is C equals to C of T. Point number 4. Specific heat is essentially a measure of how thermally insensitive a substance to the addition of energy. The greater a material's specific heat, the more energy must be added to a given mass of the material to cause a particular temperature change.